All right, so today we're doing minimum equals sum of two arrays after replacing zeros. So we're given two arrays, nums1 and nums2, containing positive ints, and we have to replace all zeros in the arrays with strictly positive integers, such that the sum of both arrays become equal. And then we have to return the minimum equals sum we can attain, or -1 if it's impossible. So let's look at the examples here. So here we have nums1 equals 3, 2, 0, 1, 0, and nums2 equals 6, 5, 0, right? So the output would be 12 because we can replace the zeros in nums1 with the value 2 and 4, and then we can get it to equal 11 here, and we get this to equal, I guess since we have to replace this, the minimum would have to be 12 on this one. So we'd have to get this equal to this 12. Um, so here's the resulting array. Replace the zeros in nums2 with the value 1, 6, 5, 1. You have the sum 12. Here, look at this example. This is equal to 5. This is 4. And since we have to replace these zeros with a positive integer, at minimum, this is 6. So there's no possible solution. So it's -1. And our constraints is the length has to be greater than 1. So there has to be at least two values in there. And, the max case is both of these. Okay. Let's go through it. So what I did is I got the sum of both of these lists, nums1 and nums2, and these zeros, the amount of zeros. And so we replaced every zero in nums1 and nums2 with 1 to get the minimum case, right? So we get the minimum value, and we make the value of the sum 1 greater, because if we're replacing a 0, then the total sum will grow by 1, right? So so we replace nums I with 1, we increase the sum by 1 of each, and we, I guess, keep on going. So the amount, we count the amount of zeros, I guess, we replace. We do the same thing for this. Now, if x is greater than y, so this is if nums1 is greater than nums2, the sum, and 0, 2, so the amount of zeros in the nums2 is 0, or if y is greater than x and 0, 1 equals 0, then we return -1 because there's no possible solution at that point. And then these are the two alternate cases. If this nums1 is greater, then the solution to make, I guess, so let's say, or I guess we'll go through this one. So we replace this with 1, so this is 12, right? And these are all ones here, right? So 3, 5, 6, 7, 8, right? So we just replace one of these ones to go from 8 to 12, and that's essentially what we do here. We just subtract the difference and add 1 to get that difference of 12. Opposite side, and we just return either or. And if there's no solution, we just or I guess if they're the same, we just return x here. And we can run it. And we see we passed both test cases here and here. And then we can submit it. And we beat 42%. And yep, that's about it.